Hello, boys and girls. This is Mr. Newman, and today we're going to look at a division problem together. So make sure you have your math notebook out to take some notes, and there will be a problem at the end that you can try on your own. All right. We have a word problem today. It says there are 86 people waiting to ride the train at a zoo. Each car on the train can hold 6 people. The equation can be used to find the number of cars, C, needed for all 86 people to ride. So we have 86 people divided by groups of 6 equals C. Remember that 86 people want to ride the train at the zoo. Each car can only hold 6 people. How many cars are needed for all 86 people to ride? And we have a multiple choice answers here. We have 14 cars with 2 people in the last car, or 14 cars with 4 people in the last car, or do you need 15 cars with 2 people in the last car, or 15 cars with 4 people riding in the last car? So since this is just if you notice here, this is just a two-digit divisor. This is the divisor. Two-digit dividend, this is the dividend, the large number that you're breaking up equally into 6 groups. Since you only have a two-digit dividend, the best method here, in my opinion, is to do an area model. And we're going to look at an area model 2 different ways. We're going to do an area model with a number bond and an area model with an area model. The reason we're going to do a number bond today is because this shows up on your weekly review. So we're going to approach this problem 2 ways, with an area model, and then we're going to do a number bond. And these are very, very, very related. Number bond. So just a little chart here just so you can see the difference between the two. I'm going to start with the number bond. So remember our equation is 86 divided by 6. So I'm going to start with the total, which is 86. I'm just going to circle that, and this is my total. And I'm going to break this number up into a bond of numbers. And what I break it up to must equal the total when I'm done. It has to equal the total, which is 86. And since I'm dividing by 6, I'm only going to use numbers that I know are multiples of 6. For example, I'm going to start with the number 60. That's my first bond. And the reason I chose 60, because 6 times 10 is 60. So that's an easy number to work with. I can easily divide 60 by 6, so that's why I chose 60. What's left over? Well, you should say, 26 is left over. It would take 26 added back to 60 to get back to 86. But 26 is not a multiple of 6, but 24 is a multiple of 6, so that's what I'm going to use. That's the next closest number without going over 26. So far, if you look at your bond here, we're back to 60 plus 24 is 84. That's 84 between these two numbers here. That's 84. And I have to go to 86, so I have to have at least 2 more. So I'm going to draw just another bond here. I'm going to put a little square around this one, not a circle, and I'm just going to put a 2 there. Because now if you notice that 60 plus 24 is 84, plus 2 is 86. So all of these bonds here get back to 86. Why did I break it up into 60, 24, and 2? Because these two numbers are easily divided by 6. This number 6 cannot go into 2, so this is going to be your leftover. This is going to be your remainder. So I can easily set the problem up like this. 60 divided by 6, okay, and then 24 divided by 6. And that equals, let me say equals, and I'll put it down here. That equals 10. This equals 24 divided by 6 is 4. And I'm going to have to add these two numbers together, 10 plus 4, which equals 14. And we cannot forget about this leftover here. This is what's left over, so that's remainder 2. So this is what you call a number bond. It's pretty easy, and it works really, really well with two-digit dividends, 2 digits. I wouldn't really recommend it when you get into 4-digit dividends. 3-digit dividends is still okay, but when you get into a 4-digit number that you're trying to divide, I wouldn't recommend the number bond. Now let's go back and look at an area model and see how these are similar. Let's see how these are similar. So an area model is going to look like this, and you've been working on area models for a while now. So this is my area, which is 86. And remember, I'm dividing by 6, so I'm going to call this my length, and I'm looking for the width there. That is letter C. That's what we're looking for. So this says 86 divided by 6 equals C. Now, I am going to not use 86 as my area. I'm actually going to use some different numbers. I'm going to break it up into numbers that are multiples of 6. So, hey, let's do 60 and 24. Let's do 60 and 24. And we're dividing by 6. So 6 times 10 is 60. 6 times 4 is 24. And then, remember, this only equals 84. I have to go to 86, so this is going to be your little remainder here. I'm just going to put a small box with a 2 because 6 can't fit into 2, not even one time. So that's going to be your leftover. So look at the difference, look at the similarities here between the number bond and the area model. They're basically the same thing. It's just a little different, got a little different look to it than the area model. So you can actually use both of these or either one to come up with the answer here. Some people like number bonds, some people like area models. I'm a bigger fan of the area model, but both of these show the correct answer. So if you add your two quotients up here together, we get 14. I'll just put C equals 14, and then this part right here, this is what 6 cannot fit into, so I'm just going to say remainder 2 left over. So this is our answer. We showed it two different ways. I'll put C equals 14, remainder 2 over here too, just so you can see. So when you're doing your weekly review and it asks for a number bond, take a look at this. Take a look on how I did this number bond. Okay, and this is the area model. You can see how they are very closely related. Now let's go back and find our answer. So what does 14 remainder 2 mean? We have to interpret this answer with this problem. Does it mean it's either going to be probably A, which is 14 cars are needed with 2 people left over, 2 people riding in the last car, or it's going to be C, 15 cars with 2 people riding in the last car. I know 4 people are not going to be riding in the last car, so I can get rid of B. And I know D is not going to be it because we don't have 4 people in the last car. So do we need 14 cars or... Oh, underline the wrong one. Sorry. Do we need 15 cars or do we need 14 cars? Is it going to be A or C? Now, keep in mind, 14 cars, these cars are completely full of people. There are 6 people riding in all 14 cars, and remainder 2 means 2 people are left over that are not in a car yet. So, do they need to run 15 cars or do they need to run 14 cars? Think about that. And you can always check your work by taking 14. That was my quotient, my answer, multiplying it by 6. And notice 6 times 4 is 24. 6 times 1 plus 2 is 84. I only get 84 people if I only have 14 cars. So I'm going to let you decide what the answer is. Is it going to be C or is it going to be A or is it going to be C? Think about that when we go back and check our work. And how do we get back to 86? Well, keep in mind you have to add your remainder back to your answer at the end. If anytime you have a remainder, you got to add that back when you want to check your work. And see, we get back to 86, so you know the problem's right at 14 remainder 2. But how do we interpret the answer? Anytime you get a remainder and you're working with a word problem, you got to use that remainder. How are we going to use it? Do we need 14 cars with 2 people in the last car or 15 cars with 2 people riding in the last car? Remember, we have to get everyone a ride on the train. How many cars do we need? Will 14 do it or do we need 15? All right, I'm going to let you decide that answer. Take a picture. Tell me why you are using A or why you are using C. Why you're using A or why you are using C. So pause the video, write your answer down, give me a short sentence explanation of why you picked C or why you picked A. Okay, the next part of this lesson, we're actually going to go to your weekly review 2.5. This is this week's weekly review, so make sure that you notice that this is a question straight from your weekly review this week that I am going to help you with. So let's go. I want to go to number 7 on the first page. Number 7 on the first page. So I'm going to zoom in down here to number 7. On the first page. This is 1,352 divided by 4. Now notice you have a 4-digit dividend, a 4-digit dividend. This is your dividend. This is your divisor. I would not recommend doing an area model here. You could definitely do an area model. You can definitely do a number bond. But I would recommend the standard algorithm of division. And I haven't showed you the standard algorithm till just now. So now I'm going to show you the standard algorithm of division. And yes, this is most people's favorite because you can do it quickly and it just works. There's not a lot of guesswork to it. You just follow the steps and it's pretty easy. But I don't want you knowing this is the only way to divide because it's not the only way to divide. So this is the standard algorithm of division. We're going to follow these steps. It's called divide, multiply, subtract, and then bring down. We're kind of going to follow this process over and over again until we finish the problem. So the first thing I'm going to do is set this problem up. And the way I do that is I'm going to write the dividend, which is the large number here, 1,352. And I'm going to say divided by, I'm actually going to use this divided by sign. It kind of looks like an upside down kind of 7. And I'm going to put 4, the divisor here on the outside. So basically I'm taking this number, 1,352, and dividing it into 4 equal groups. So I'm going to change my color here to red. All right, so we're going to follow these steps. Divide, multiply, subtract, bring down. So we're going to take the 4 and we're going to try to divide it into the very first digit that we see, the very first digit that's closest to my divisor. In this case, it's the 1 in the thousands place. So I'm actually going to put fill in the blanks up here, 1, 2, 3, 4. So I have a 4-digit dividend. So I'm going to have 4 digits up here in my answer column. And this is the answer column up here. This is going to be the answer column right here, also known as the quotient. This is the quotient. So divide. Can 4 fit into 1? And I only really want you thinking about is this is just a 1, right? I know it's in the thousands place, but we're going to just pretend like it's a 1. Can 4 go into 1 evenly? You should say no, 4 cannot go into a 1. So we're not going to have any value here. So I'm just going to put an X. No value there. 4 can't fit into 1. So then I'm just going to scoot over one more place value and look at 13. So 4 can't go into 1, but can 4 go into 13? Yes, 4 can go into 13. And you could do the multiples of 4 over here if you don't know this. 4 times 1 is 4. We can get bigger than that. 4 times 2 equals 8. We can get bigger than that. 4 times 3 equals 12. That's going to be just right. Because if I do 4 times 4, it's going to be too big. That's going to be 16. So I want to use the best number. So we're trying to divide 4 into 13. Remember, this is the D step, divide. So 4 can go into 13 3 times. I'm going to put a 3 right here in the hundreds column. And then I'm going to, see the M, I'm going to multiply. I'm going to say 3 times 4. And anytime I round this corner, I'm just going to think of multiplication. 3 times 4 is 12. And I'm going to write that underneath 13. And then I'm going to do the subtract stage. So I'm going to subtract 13 minus 12. And I know this is 1,300, but we're just pretending like it's a 13. So we're basically subtracting the thousands place and the hundreds place. So when we subtract that, we get 13 minus 12 is just 1. And anytime you subtract, you have to get a number that's less than your divisor, or you did not pick a big enough number right here. So 1 is less than 4, so it's a good number. Now we're on the B, the bring down stage. We're going to go to our next digit in our problem that we haven't used, which is the 5. And now we're going to bring that problem down. I'm going to bring that digit down. We're going to take the 5 in the tens place and bring it all the way down to this 1. So now we have 15. So now our problem is moved down here. This is 15 divided by 4. 15 divided by 4. And you should know how many times 4 can go into 15. If you don't, come over here and do your multiples of 4. I already have my multiples of 4. 4 times 4 is 16. That is too big, so I cannot use that. I have to use the best number, and once again, it is going to be 4 times 3 is 12. So 4 can go into 15 3 times. I put a 3 right above the digit that I brought down, and then I multiply. 3 times 4, which is 12, and I stack that underneath the problem that I just tried to divide 4 into. So notice we divided again. We just kind of restart this whole process. Divide, multiply, subtract, bring down. We said how many times can 4 go into 15? That's the division stage. And we said 4 can go into 15 3 times. So that we divided and we multiplied. 3 times 4 is 12. Now we subtract. We subtract 15 minus 12. And I get 3. Is 3 less than 4? Yes, so we picked a good number. We picked a good number here. So now we're at the B stage again, right back to B. We're going to bring down. Do we have any more digits to bring down? Yes, we have this 2. We're going to bring that 2 all the way down to the 3. And now we have 32. Remember, the problem moves downwards. The problem moves downwards. So we're looking down here. 32 divided by 4. So now once again, we're back to the division stage. How many times can 4 go into 32? We used to say, oh, well, 4 times 8 is exactly 32. So 4 can go into 32 8 times. And notice I put the 8 above the digit that I brought down. So, and then I multiply. 8 times 4 is 32. I stack that underneath the problem that I'm looking at. I subtract that, and I'm at this stage right here. I get 0. I get nothing. And then I'm at the B, the bring down, and notice there are no more digits to bring down. So this means you are finished with the problem. This right here would be the remainder. The remainder is nothing. You have no remainder. So this problem works out evenly. It is 338. So 1,352 divided by 4 is 338. That is your quotient, your answer to this division problem. And this is called the standard algorithm of division. And this is the steps we follow. Divide, multiply, subtract, bring down. And this is just something you're going to have to practice to get good at. So I'm going to give you a problem to try on your own. I'm going to give you a problem to try on your own. So make sure you put this in your weekly review because this is the answer to number 7. This is the answer to number 7. Now, when do I recommend the standard algorithm? Is when you have a 4-digit divisor like this. And you're going to see these this year, definitely. I recommend the standard algorithm. If this was only a 2-digit number right here, then I would recommend doing a number bond or doing an area model. But since this is 4-digit, I like the standard algorithm. So let me give you guys a problem here. Let me just go down here below number 8. And I'm just going to make up a problem for you to put in your notes. And this might have a remainder. This may have a remainder. I don't know. Let's do 1,792 divided by 5 equals, we'll say, equals n. Now, I know this is going to have a remainder because you should know that 5 only goes into numbers evenly that end in a 0 or a 5, and this number ends in a 2. So this will have a remainder. Try to do this problem using the standard algorithm. Okay? This is your try it problem today. Try it. Try it. And the only way you're going to get good at the standard algorithm is you practice it. So if you want to practice the standard algorithm with some of your IXLs this week or some of your con, that is a great idea. Try it out. Remember, approach division using multiple strategies. Don't be someone that only knows how to do one strategy. Try to do all the strategies. Try area models. Try number bonds. Try the standard algorithm. Some strategies work better with different problems. So be someone that can divide using different strategies. It will only make you a better mathematician. Okay? So This is your try it problem, 1,792 divided by 5. Make sure you take a picture of this problem in your notes. Try to do it using the standard algorithm of division. Go back and watch me do this problem again, and you try it with this problem, 1,792 divided by 5. You will get a remainder. I'm telling you, you will get a remainder. So if you don't get a remainder, you did something wrong. Okay? All right, guys. Questions, comments, let me know. You guys have a great day, and I'll talk to you soon.
See you, bud.